Hello, and today we're back doing testing, and we're doing an EICR. Enjoy. Okay, good afternoon everybody on this rather cold day. You have to forgive my voice. I've actually come down with a cold. Not COVID, I've just done the test, so it's a cold. However, this video is actually connected with another video that I did that was about restoring power to a garage. I'll put the link to that video up there. This is the EICR part of this video, part of this series, sorry. Now it's a bit of a truncated video because, as you'll see when the video is being done, I actually came across a bit of a problem which meant I couldn't continue the inspection. So what you'll see is the inspection that I've been able to do so far. Long story short, there's a problem with the consumer board which I've got to put right. I can't put it right until a isolator switch is put in, which is going to be another couple of weeks. Once that isolator switch has gone in, I can do the repair I need to inside the consumer board, which you'll notice, and then I can carry on. But for me, not the client, for me, I did not feel safe tinkering around, unhooking wires and doing testing with bare wires on the tails. I wasn't going anywhere near those. I've been shocked by tails once before in my career and never again. It hurts. Anyway, so just wanted to go through that. So this video will be go through what I normally do for an EICR. Like I say, it's not a complete video, and the rest of it, once the isolator switch is done and I can do the full testing side of things, you'll see that when it comes done. I am able to do the testing on a sub-board that was in the house, so you will see that, and you'll see me do some other bits and pieces as well. So, what do I normally take with me to do an EICR? Well, normally I go with this great book. This covers everything you need to know about doing EICRs and the coding you're supposed to use. Great thing. I always take it with me, and I actually go through the book from start to end, because I do obviously a visual inspection first and then I go on to do the testing afterwards. Anyway, am I qualified to be doing this? Yes, I am. $23.91.52, which is the I'll just read it out. The award in initial and periodic inspection and testing of electrical installations. You are supposed to have this qualification to be able to do EICRs. Anyway, it's an incredibly difficult course to pass. I believe the current pass rate is 30%. So there you go. They are very, very strict. Normally when you're doing sitting guilds, the practical side of the exams, you're normally given 3 chances to get something wrong before they say, no, you failed. In this one, you are given no chances in the practical. If you do something wrong, that is it, you have failed. It's as simple as that. And it's understandable. You are dealing with something that will not only kill you, but can kill the client as well. So if you go in there and you do just one thing wrong or one thing in the wrong order, gone. No chances. Anyway, so yeah, if you want to do inspections and things, it's well worth trying to get on and trying to pass. Like I say, most people take 2 or 3 attempts to get it. I did it first time. However, I know I'm blowing my own trumpet there, but I have been doing testing and inspecting and all sorts of things for about the last nearly 18 months before that as well, as I was trying to get my other courses under my belt, which are over here somewhere. And they're in there somewhere, they're in my folder. So I was, you know, my tutor said, if you don't pass this first time, you shouldn't be an electrician, because you've done this to death for ages. Anyway, I'm really waffling, I do apologise. But yes, this now, this particular course is now a requirement of being on the, certainly on the Napit competent person scheme to be an inspector. I can't speak for NICEIC. EICR. If anyone knows, please stick in the comments. But not only that, my insurance company wouldn't let me do inspections or anything else without having that, so I wouldn't be insured to do it anyway. So yeah, I can also actually do inspections for I can do third-party inspections now for other electricians. I don't do that as a rule, if I'm honest, but I have done it for other people, so it can be done. Another part of the video that I will do when I've actually completed this EICR is I will run through the paperwork that's involved in doing everything as well. That will be a long video. It'll be quite, you know, but I think hopefully it'll be informative as to, you know, there's a lot of red tape with the EICRs if it's done properly. Yes, a lot of it is I would say is down to interpretation. Almost certainly other electricians who maybe watch this video will say, no, I would have coded that a C1 or a C3 or an FI. Everyone's entitled to their opinions. I don't think there's any right or wrong in doing this. So long as, let me be, you know, if you see a connection where there's bare copper, well, there's no, you know, it is a C2 or C1 depending on where that bare copper is. You know, if it's outside the consumer board, the tower's going in, and you can see bare copper, that's a C1. There's no question. You'll notice in the video, by the way, and I will correct myself here, I was going to code what I found inside the board as a C1. That is incorrect, and I knew that afterwards. I coded it a C2, and the only reason for that is, in order to get a shock off it, you'd have to get the cover off, and you're not supposed to be doing that unless you're a qualified electrician. So it's a C2. I did say in the video, or I will say in the video, it's a C1. Forget that, it's a C2. The bare copper that's showing on the incoming table. That still needs to be corrected though. I can't think of anything else I changed my mind on from the video to this, but if there is, when I do the next video on filling in the paperwork, I'll show you what it is. So yeah, I normally spend roughly an hour or so doing the visual side of things, and then I'll go around and do all the testing. As you'll see, the only testing I have been able to do is on the subboard. I haven't done the testing on the main board yet. Apart from the RCD, did do the RCD test, and I've done the ZE and I've done the LPO. I've done those. Those I could do fairly safely. Other than that, I couldn't safely, or I felt I couldn't do it safely to do anything else in there. Anyway, 9 minutes this has taken. If you're still with me, I do hope you find this video informative. Definitely open to comments if people think I might have coded something wrong or missed something. Certainly if I've missed something, stick it in the video, because I've not done the paperwork for this one yet. So if anyone does see something that I've missed, you know, please put it in. I'll be, you know, a second pair of eyes is always useful with these things. And I will get back to comments. Anyway, so please, you know, it'd be great if you could, if you enjoy these videos, please do press the old subscribe button, and as I say, comment, and I will try and get back to people when I can. But anyway, I shall set the video rolling and enjoy. Okay, so we're doing an EICR today at property where we've got some additional work to do, and we'll come to that later on. But I thought I'd do a video on, I can't see a thing there, there you go, on how I do an EICR on a property. So we've got 11 circuits which we'll go through, but first what we're doing is we're going to do a visual inspection, which will take about an hour. So I'm going to go through what I've spotted already, because I've had a few looking around, and I'll show you where we are. Oh dear. So, okay, so we're in the cupboard, and it's going to be rather difficult to see. Let's just get the... There we go. It's better. Right, so we're going to start off with the incoming cable, which is absolutely fine, no problem there. Come up to it's a 100 amp fuse, and as you can see just about there, it doesn't have a lock on it. I didn't realise that. So there's no lock on the fuse, top or bottom, I don't think. Nope, there isn't. So okay, that's a DNO problem, anybody. So over here we have, so it's a TNCS system. Over here we've got the correct earthing cable going off up there, that's fine. And we've got one earth cable going off, that's fine. I've already checked, the water pipes are plastic so they don't need bonding. So that will be the gas pipe bonding. I have not been able to locate anywhere where it's connected, so that will have to go down as a limitation. There is a gas cooker, but it's and gas heating, but I can't get behind the, sorry, not gas cooker, gas hob, but I can't get behind the gas hob, so I'm assuming that's where that cable goes off to, because it doesn't go to the gas meter outside. So that's that bit. Up here we've got no problem with any bare cable showing, that's all fine there. You could argue, is that cable neat? Well, maybe, maybe not. So we could code that as a C3, maybe. I might say that's okay. I'm not sure yet. Anyway, the meter tails are the correct size. Now we're going to come to the board. This is where the first issue is that I have actually found. So we've got a brand new board. This was put in 2019. As you can see, there's no labelling on it whatsoever. That's the first problem. And the other problem is that. So we've got the line and the neutral not going in through the same hole in the bottom in a metal enclosure. Now, if there was any sign of any singeing or anything on those cables, then it would be a C2, because it isn't, it's a C3, which is the recommendation that they should go through the same hole to avoid electromagnetic effects. I'll detail that later on as to what that means, because I appreciate that means a bit weird. So at the moment, that's where we are with that. Let's turn it around that way. So we've got, it's a BG board. Again, there's only the labelling that's supplied in the BG board, and all the circuit breakers have been labelled up. We've got two RCDs which I'll need to test. A couple of those circuit breakers aren't labelled, but when we come to doing the actual testing, then we'll make sure that all of this is all labelled up correctly. So I don't have a problem with that, that's fine. So as far as I'm concerned, that's the first part of this visual inspection done. I don't see any other issues on that. Just as an observation, just as a side note, as you can see, all the cables are going down and then into the floor. So let's bear that in mind. Now, if you count up the cables, we've got 1, 2, 3, 4, 5, 6, 7. There's only 8 cables coming out of this. And we've got 1, 2, 3, 4, 5, 6, 7, 8 MCBs labelled. So, those ones that aren't labelled, I could probably assume aren't connected. Okay, fine. So we've got a big thick cable there, which is probably the cooker. Two, like 2.5 cables there, probably the kitchen ring. Then we've got a really tiny one, and I don't know what that is. That could be the upstairs lights, but that's very tiny. Then the next one along, 1, 2, 3, 4. 1, 2, 3, 4. Next one along is downstairs socket, so it looks like the kitchen is on its own ring. Then we've got that's definitely a lighting cable. And then we've got one that goes off to the conservatory. Now that is actually quite big. That looks like a 4mm. And then we've got one at the end. And that's a round one. I don't know what that one is. That's interesting. I wonder where that one goes. Right. Okay, so we're in the kitchen. So let's start with the kitchen. So, as I say, we've got a cooker to do, and there's the gas hob. So we already know that there's a problem with one of these sockets, one of these switches. That switch. Oh no, it could be that one. Right, one of those doesn't work, so just put my tester on it. Oh, it does work. Hang on. Oh yeah, so that one won't accept anything into it, so we'll get that sorted out and replaced. So we've got, let's just go around and just check them. Yeah, that's fine. And we've got, so that's the cooker plate for that. Let's just check it, because this will be on the cooker circuit, a different circuit altogether. Let's just check it out. Yeah, it should be fine, but we can do our R1, R2 tests at that point, so that's helpful. We don't have a electric shower here, so that's fine. Okay, so let's count up the number of sockets that we have. So we've on the ring. Hang on. So we've got one socket on the cooker circuit, then we've got 1, 2, 3, a few spare for something which we need to check on, 4. So it looks like there's 5 on the kitchen ring, so bear that in mind. No, I'm not seeing any. The only damage we're seeing is one on that socket there, no other damage to anything else by the looks of it. Be interesting to see what that fuse spur is for. But we'll check on that. Okay, so that's fine. Lighting. Lighting. So we've got metal fittings, so I will need to check to make sure that they've got earthing to those, but that'll be fairly straightforward, so we'll be able to do that, that's no problem. Okay, so we come on to this area now, so it'd be interesting to know whether that is on what lighting circuit these are on. So come down here, and we should have, probably down behind there will be a socket. Well, there is a double one. It's actually underneath. Let's just check it. Right, it is up there. It's there. Right. Okay. As you can see, there is actually a bat box with nothing on it. That's interesting. And then we've got a double socket there. Oh my word. Right. Okay, that's yeah. Okay. That'll need a bit more of investigation later. What is going on there? Right. Okay. Yeah, that's an aerial coming down there, as you can see. That's an aerial. But I don't put a socket cover on it. Righto. Okay, so we've got the double socket there, which we know that it's not an electrical problematic, it's an aerial thing, but we need to check it. We've got a double socket there, so that's 2 in this section, 1 there, so that's 3 in this section. Okay, so it's 3, oh no, we've got 4, there we go. So it's 4 there, there's no cracking or anything on those. So we do need to check that one behind the TV. We're on a different circuit, so let's just, whoops, fingers in the way, look at that. Let's just check one of these, because these will be on a different circuit now. Oh, I'm on the wrong way up. Yeah, okay. Righto, so we're reasonably happy with that. Obviously the testing will show whether we've got any specific problems with the ring. But I think we're okay there. Now the conservatory is slightly different. It has that 4mm cable coming here, and I'll show you why. Because we have another consumer board. Now, this one's plastic. That's absolutely fine. It's in good condition. It's in good nick. Let's get the light on. There we go. So it's in good nick. It has been labelled. I'm not entirely sure why that switch is in the off position. The one that is in the off position, that external electrics, is off, because we do know there's a problem with the wiring outside, which I will show you in a minute. And that's why that's off, because every time it goes on, it trips it. So there you go. So we've got a main switch. So we have a main switch and what looks like an RCD to the left, which is off, and I don't know why that is. So we need to investigate that. Right, okay, let's see how many sockets we're playing with in here. So obviously there's a socket for the washing machine. So there we go. So we've got 1, 2, 3, 4, 5, 'Looks like there's a blank plate behind that radiator, so I need that. Now we do know that the outside electrics come off behind here somewhere, so we do know that. No, pussycat, where was I say? There's another plug down there. There's another one. Oh, and down there there's another one. There we go. So I think that's it for in here. Lighting. Now we've got spotlights in here. Okay, which I recessed into the ceiling. Whee. So yeah. So we can't test on those, but we're going to have to do that on the switch. So let's just check the switches out. Let's just check them. I think I only got that one. Okay, so we do have wall lights and those. So we've got switches, no damage to the switches, they work. Let's just get the tester and test on this because this is on a different circuit. Okay, there. check this one. Oh, we've got another one. That's an interesting plug socket. Right, let's just check this one. Yeah, that's fine. Right. Moving on to the hallway, we've got light switches here. That one turns on the kitchen light. So does that one. And that one turns on the lounge light. Okay. So do we have any light switches elsewhere? No. Okay, so we know we've got... Let's go quickly. So we've got another metal fitting there, which I'm assuming is... So that light switch is there. Just go outside just a second. So we've got a PIR and a light there. I don't see any problems with those except they're a bit on the grubby side. We do have an outdoor socket. Let's just see if it's working. Yep, so we've got a working outdoor socket. In the hallway we've got a double socket. Let's check on that. Check that one. Okay. Double light switch, which is doing that light. Bathroom. So we've got a fan and a light, and we've got an isolator for the fan, which, as you can hear, is all working fine. It's fine. Okay. Okay. Is it all right to come in, Kay?
Yeah, of course it is, yeah. You don't mind me being here, do you?
No, it's fine. Right, so more metal light fittings there and there. Let's check them. Okay, I've got a failed bulb there, but that's okay. And a failed bulb there, and nothing happening over there. Okay, right, not a problem. Turn that off. Okay, so we've got one socket there. There'll be a double socket beyond there. Almost certainly. Yes. In fact, there's two double sockets down there. That's fine. Okay. Right, what's going on behind there? What's going on down there? Right, okay, so we've got a potential problem there. That socket is loose off the wall. So we need to have a look at that at some point. I've got a socket there. Check it. Okay. Oops, that's fine. Okay, so we've got a light there. I'm not going to be able to get to that. Right, socket on the landing. Let's just check it. Okay, and we've got a light switch. couple of failed lights there. Okay, we've got a smoke alarm. Need to check and see if that's on the electrics. Right. Assuming that's for this bathroom. That switch. Yes. The fan's started up. We've got spotlights. And the extractor fan is there. There's no sockets in here. There's no shaver points in here by the looks of it. Nope. Fine. And it's, as I say, we've got no electric showers. So there's nothing for that to worry about. Right. Okay. Bedroom. We have a non-cracked light switch. Oops, yeah, just check the light. It's fine. I've got a pendant light on this one. That could be useful for doing the testing later, so that's handy. Well, I could test the switch, I suppose. We've got a socket there, so there's two sockets in this bedroom, by the looks of things. Yeah, okay. Let's just check it. Okay, that's fine. Next bedroom. Just the light is fine, and another pendant light which we could check if we need to, or I might do it with the switches. So in here we've got double sockets, which are fine. I think they might actually be the only ones. I think. Might be the only ones. Oh no, no. There you go. Another one there. Always have a look round. What's the thing with this? Okay, so that's that room. Last room to check. We have a light switch. We have a light switch. Right, with a light. Oh, the light's over there. There we go. Right, well there you go. Okay, does that need to be checked? I don't know. Now we do have floorboards. Okay, so we've got floorboards here. We have access to floorboards here. This could be useful for later on. I'll explain why later that could be useful. Okay, so we've got switches here. That one appears to work. We've got that light is working. I'm not seeing any sockets yet, which is interesting. Okay, that's working. I'm not seeing any sockets in here, but there must be, because we've got a TV there, so that must be getting its power from somewhere. Oh, there we go. So there is a socket, it's hidden. So there is a socket in here, but there might well be another one, maybe. We have a sink in this room and a plug over there. Right, okay, bear that in mind. Right, so we do have a sink and we've got a light fitting there. I need to check my special location rules for this. That's a surprise. This end of the room won't be a problem, but that end I need to check the regs. Okay, so right in the garden now, let's have a look. Now we do know this is where one problem is because we're well aware of it. So we have here, it looks like it's a fused spur. It looks like it's been put in a fair while ago. There's an RCD power breaker there by the looks of it. And then that pipe goes down, it goes under this patio. It heads up here to this. As you can see, it's off the wall, but the main problem is the SWA cable. If I bring it down, I don't know whether the camera's bringing that up, but that has been quite badly damaged. Now, every time the circuit breaker is put on for this, it trips out. So my guess is that that is the reason why. I think water's got into that cable and that's what's tripping it out. So we'll obviously have to code that up, but what I'm going to do is I'm actually going to, because the client wants me to rewire the garden anyway, so what I'm going to do to make it safe so we can actually get the power back on properly is we're going to disconnect all of this wiring here into all of those, make it all safe, and then we can worry about getting the wiring done, because what happens after that, the wiring then from that point heads up over here, back here, and that's that cable there, heads up and over to that junction box there. Now I've checked it, that junction box is fine, it's completely dry inside, it's well terminated, so I'm not worried about that. What I'm worried about is back there where the cable's been damaged. So that box has already been checked. I checked that when I came here the first time, so I don't need to worry about that. But that's where that is. That's where we are with that. There's no other power to the garden. Next thing to check will be the garage, and the garage is where the interesting issue is, because I'm supposed to be putting power back to the garage. What used to be power to the garage, there isn't anymore, and it was taken away a long time ago. However, the cable for it still exists. But it's not connected to anything. So I'll go and show you that cable. As I say, it's been recently rewired back in 29, but it hasn't been done well, as we've already discovered. The client had to tell the electrician concerned to leave site before it was all finished, so that's why there's no inspection notices and all sorts. So my guess is when I come to do the actual testing, I'm going to find a whole world of problems. But anyway, what I wanted to show in here is that we've got an old fluorescent light tube. So like I say, there was power in here at one time. That cable goes across there to that junction box, and I don't know about the ladder. I think that, yeah, that's been disconnected. You can see the cable's been cut by the looks of it. There is a light switch. Those of a certain age will recognise those old Baker light switches, which is absolutely fantastic to see. They belong in a museum. So as you can see, there's been a lot of cables being cut, a few spurs off. I'm pretty happy with, after coming here before, that there is no power. There's nothing live in here except for this. As you can see, there's a cable there. Now, to my mind, that looks like a 2.5mm cable. It goes in a tube, it goes under the patio into the house. At the moment, we do not know where that heads for. However, it goes up here and is wound all over there. But if you look here, it's just been left cut. Now, it's actually a modern cable, so that could only have been put in the last few years. It couldn't have been put in long ago. Now, as I say, the question is where does that cable go after it gets into the house? There's multiple possibilities. In line with the route of that cable is a socket in the kitchen. It's possible it's been just pulled off that. Alternatively, that cable, I don't think that cable now, when I think about it, goes back to the main board, because I've identified all the cables going to the right places, so that's unlikely. So the only other place it could be going to is the other board behind the washing machine. Now, a little bit of background. The original reason for coming to this particular property was to actually get power back to the garage. And then with a longer chat with the client actually wanted me to do an inspection because of what had happened in the past. So the inspection should find out where that cable's coming from and whether it's live, for that matter. Which I hope it isn't. Anyway, we'll have to put that down on the draft EICR that I'll draw up. It's going to fail because of some of the things I've found anyway. But they're going to be put right, so that's not an issue. So anyway, like I said, that's an old fluorescent thing. That's going to be replaced with a modern LED one, so that's going anyway. But the client wants lighting back. She basically wants power back in here. To start with, getting the lighting back up because she's using a business from here. So initially there's going to be lighting in here, then there's going to be power, then there's going to be a new summer house built out the back which needs power, and there's going to be garden lighting which will also need power. So once I find out where that cable's going, if it is going to the back of a socket, I don't think that's going to be good enough for the plans that we have for everything else. We might have to get creative, shall we say, in how we get power out here. It's a shame because that pipe work is there. If we could reuse that, ideally I'd like that cable going back to one of the two boards. Then I can rerun a bigger cable, maybe a 4mm, maybe even a 6mm to deal with all the power that's going to come out here. But a 2.5mm just isn't going to work. It's too small for what we need it to do, especially if it's just been pulled off the back of a socket. Anyway, that finishes the visual work. So I'm going to take this video back with me and use it to actually do the paperwork. But now I need to decide what I'm going to do next. Now, so I'll just come outside, it's lighter here. So that's the visual inspection done. Now, when you do an initial verification, you're dealing with a dead system, so you would do it in the order. You check your earth bonding, you do your the radials, then you do your finals, and as I say, and then go on from there. But this is already a live installation. The complication on that is the person works from home, so I can only have the power off for a limited amount of time. That's why this particular EICR is going to take a day or two to complete. Normally we've got 10-11 circuits to deal with, as you've seen. Probably would have done that in a day, but on this occasion I can't, only because the person works from home, so I'm going to have to split it into a day or two. Now, because I'm dealing with a live system, for me it kind of makes sense to do things in reverse. So, and that's to do the RCD tests now, which normally would be done at the end. But the power's on, so why not do them now? We might get them out of the way. Then I'll do the LPF and external ZE. I'll do the ZE test, get those out of the way. So to get the live testing done first, before I then turn the power off. Put some notes in the comments if you would do things differently when you're doing any EICR. Would you turn all the power off and go from dead test to live? Or would you do what I'm doing and go from live and do effectively backwards? be interested to know what other people would do. But I'm just looking at it, I'm just thinking, yeah, power's on, why not just do the live test while the power's on? I don't have an isolator switch here, which is a bit of a shame, so I can't isolate all the power, so it's just powering it all down. But anyway, so yeah, so I'd be interested to see what other comments people would do. So for me, I'm going to go and do the RCD tests. Now there are 1, 2 tests to do, and there's that odd one that's currently in the off position, which I don't know why. So need to find out why that is. Could be a faulty RCD, that's why it's off. Need to check. So there's 2 RCDs to do in the main house, do those. Then do the one in the conservatory, see what's going on with that. Then I will do the LPF and ZE test, get those readings done. Then after that it is dead testing. So the power will go off, safely locked off, and we'll start with, for me, I know you're supposed to do radial circuits first. I like to get the rings out of the way first because they take so bloody long. So anyway, so let's go and do the RCD tests. Right, that socket is on the kitchen circuit because I've just turned it off. And let me see, 0. So this is on the kitchen circuit, which almost certainly means that this one is as well. Let's just double check. Yep. Okay, so all these sockets in this part of the house are on that breaker. Let's just check this one. Yeah. Okay, so I need to find a socket that isn't on that circuit. Let's try this one. There we go. So we can use that one for the next one. I'm just going to check this. Let's turn that on. Let's make sure that is what I think it is. So downstairs sockets. Is that one? Okay, so we do know that that's that. So let's test this RCD next. Okay, so I've plugged in. Let's just set it up and let's give it a try. Okay. Yes, the right RCD's gone off. Okay. Okay, let's check the readings we have on here. So we've got 27.6, 37.2, 8.4 and 14. There we go, so that RCD is absolutely fine. So that's 2 of them done. Let's go and do the one in the conservatory. Okay, I'm going to take a fly here. Because I think this is connected back to the main board. In fact, I'm almost certain it was when I remember. So it might be that RCD actually isn't, or if it is being used, we'll need to take the front off that board to find out what's going on. But let's plug the tester in and see what we get. Right, yeah, as I suspected, this conservatory is back at the main board and it flicked the far right RCD, which is the correct one, and it all passed, so we do know that. So the RCDs are working. We need to find out what's going on behind that board, but we can do that as part of the testing. So that's the RCD test done. So now we need to get the power off to the board, get it off the wall, sorry, get the cover off the wall, and we'll do the ZE and LPF tests. Might not be able to video those, we'll have to take them off at the readings. Okay, so we've got the cover off on the board, ready to do the testing. Obviously you can see straight away we've got bare copper on the incoming lines. That bare copper is currently live. We move along, there's bare copper going into the second RCD, those would be dead though. 3 cables going into that are that particular circuit breaker 32. If I look on that, that's the kitchen sockets and the dining room sockets, so there's 3 there, so possibly a ring and a radial. That's what we need to work out. The one next to it is a B16. That's the upstairs sockets according to this. That looks like it's just a radial. Okay, then we've got the lighting. Yeah, then nothing. Then the RCD. Then we've got 2 nothings, which lines up with the board. Downstairs sockets, again potentially a radial. Then we've got a lighting circuit downstairs, and the last one is the conservatory, which is on the old colours. So that's an older cable, but everything else is on the new cabling, on the new wiring. Now let's have a look at the MCBs themselves. So we have a B6 for a lighting circuit, that's absolutely fine. The B40 to the conservatory, okay. Is it the right cable? Well, that's another thing we need to look at. A B16 for a radial, I think it should be a B20, but again we'll check the regulations on that. B6 for the lighting, yeah, another B16 for a radial, should be a 20 I think. Then we've got a B32, and there's 3 cables going into that, and a B32 for the cooker. Yeah, well, we can run with the B32 for the cooker. Okay, so it looks like we only have 1 ring, potentially. Now does that bear out on the... So if... Oh dear, if the main bar's been done correctly, we should have... Okay, let's have a look. Yes, we have 3 cables. We have a big one for that one, 3 cables, yep. There was a reason we've got a blank, then a cable, then 2 blanks. Yeah, right, we'll run with that, that's fine. And on the other one, we've got the black, neutral, then a lighting circuit, and then a rate, yeah. Okay, so that's fine. So everything lines up on that. Earth bar. Got the green, missed one for some reason. Don't know why I've got one missed. And 2, and then 2. Yeah, they all, to me, they all line up. So it all lines up, but we've got a major issue with that one. I'm going to go and check the books. With that one, that's not good. Right, okay. Okay, let's go through what I've actually found. It's in section 1 of the book. So, I have found service cutout fuse carrier seal not in place, all properly secured. That's an FI, that's a further investigation, that one. Now, the other one, meter tails have exposed live conductors. They are, technically speaking, meter tails. That's a C1. Now a C1 in the book, I believe, means, here we go, danger present, risk of injury, immediate remedial action required. Now it's starred. That's an unsatisfactory report for the client. C2, potentially dangerous, urgent remedial action required. So if you bear with me a second, somewhere in the book. So page 117 of this guide, observation code C1. You can see here, an immediate risk of electric shock or serious injury. There we go. Finding C1, the inspector should contact the client or their responsible person or their duty holder, wherever they are, and inform them of the C1 observation and what the consequences are. The inspector is doing this to safeguard themselves from any possible litigation, backlash, and the inspector may give this information verbally, but it should always be backed up via a written or emailed identification. The inspector may isolate. Right, and then there's the dangerous situation report. It may stop the inspection process completely, and people are currently at high risk of injury. Right, so looking at that, right, okay, so not a good start really, is it? So there's multiple problems that we've come across with the consumer board, which we weren't expecting. So there's the meter tails going into two holes and they shouldn't be. There's a seal missing on the incoming fuse, and the incoming meter tails into the consumer board, into the main switch, have got copper exposed, which means that there's live power there. So I daren't go anywhere near the MCBs that are nearest to that. Kind of landed me with a bit of a dilemma, really. Need to think. Okay, so I still did the ZE and the impedance test. And that came out as 0.38 for the ZE and 590, 0.59 kilo ohms for the LPF. So, on the maximum. So, I managed to do that test. I am very wary about going in there to do any more testing. It's kind of left me with a bit of a dilemma, really. The thing is, the DNO is going to have to come out and put the seals back on that fuse. So if they're going to come out and do that, they might as well fit a isolator. Then I can fix the meter tails. Need to have another think. So we're back at the property doing this EICR and the garage rewire. Yeah, doing it there this week for my daughter, and I need to pick her up from the school later, and everyone, oh dear, why did I agree to that? Anyway, so yeah, that's, if you see that, yeah, that's my daughter. Anyway, so back to earlier on in the video, the DNO has been out, they've redone the seals on the fuse and other bits and pieces. We're waiting for the isolator switch to be fitted. That might be a week or two away before we can do anything to complete the EICR. But what I have done, and I'll show you in a minute, is I've done a few things in the garden to make it safe out there, so that's not a problem anymore. And we're about to do the conservatory, because I can do that because that's on a separate consumer unit, which I've currently isolated, and I'll show you that in a second. So I'm going to do all the testing in the conservatory because I can do those circuits in here. That clears it off the decks, and I can then it just leaves the circuits on the main board. Later this week we're going to be doing we're going to start work on laying a new cable to the garage, and I'll show you what we've found at the end of last week as to some of the confusion that we were getting, because my super rods are currently stuck in the pipes. I can't do it, rather, sorry. I can't pull them back, so I'm hoping they're where we think they are. So anyway, a couple of interesting mysteries have been solved about this property, but like I say, we'll show you that later. So we're going to get this board, cover off the board, and we're going to start doing the tests, yeah, we'll take it from there. Right, okay, so we can see inside this board that we do have this RCD. I don't know what that's doing, I'll be honest. I haven't been able to trace out the cables for that yet. I might have to do that in a minute. Let's illuminate it up a bit. There we go. So we've got the main tail, main switch. Those are going back to a 40 amp MCB on the main board. Then we've got. Oh, hang on. Just look at the board. So conservatory sockets are on the first one we can see, which is that one, and then we've got a washing machine circuit there, which is a ring. In fact, it's only going to that. Whoops, it's only going to those two. And then we've got two lighting circuits. Now, what's interesting about this is that this one is labelled external. Now, I've isolated the external, so I don't know what's going on with that at the moment. And then obviously we've got this one, which is the lights in the conservatory. And then we've got the neutrals are sitting on there, and the earths are sitting down there. So we're just going to go through it, and I'm going to do to be honest with you, because I can get to the sockets easily here, I'm going to do the ring for the washing machine first, which is all those two circuits there, which is this one. Only because they're just within easy reach, to be honest. So I'm going to do those first, and then I think we'll move on from there, I believe. Yeah. Okay, so this kind of shows up a bit of a problem when you're doing these tests. This is a very, very short length cable. So the readings are practically non-existent, as you can see, 0.02. So if I'm adding those two so if I'm trying to work out the earth, 0.02 times 1.67, I mean, you're going to be getting, well, the margin of error is within the margin of error. So, you know, the earth on this is probably going to give me the same kind of reading. In fact, as you can see, it's been sleeved together as well, which doesn't help. But my guess is I'm going to get a very similar, if not identical reading. Oops, if not identical reading. If not identical reading on this. So I'm just trying to get that clipped in there like that. So I've not got that clipped, have I? Let's try that again. Yeah, look, exactly the same reading. It's the cable's so short that it's not going to give me the readings on there properly. Well, we'll do the figure of 8 test because that's probably done anyway. But I'll make a comment on the test sheet. This is in, well, as you can see, it's probably barely a metre of ring cable there. So yeah, so I'll have to put that down as a comment on there. So I mean, these readings for the next set of readings probably are going to be really, really tiny, but we'll see what we get. Yeah, as I suspected when I did that test. Yeah, the readings were really tiny, so they'll have to go down the test sheet anyway. I'll just have to make a comment on, you know, the length of cable and so on. Won't get the same problem with the other ring because that's on it's around the conservatory, so that should give me some reasonable readings to look at. Never mind. Right, so we've got the other ring hooked up, and yes, there you go, 0.13, so that's a better reading. So we'll just match up the neutral lines. Just give me a second, match them up. Okay, they're on. Let's do that. 0.14, that's within the margin of error, which is 0.05. And we've got I've got to untangle that earth to get that right. Multiply at 1.67 because this is a 2.5mm cable. And then we'll do the figure of 8 tests. Not down there, sorry, on the conservatory sockets. So there we go. So I had the leads around the wrong way because my readings were increasing from that socket to that socket to that socket, then decreasing again as I came round. So that's how I knew I was getting the cables around the wrong way. So the figure of 8 cables have been put the right way round, and we're getting 0.07. So I'll take that reading around, and that should be identical all the way through. The readings I got, I think, were 1.13, 1.14, so it's 0.26 divided by 4, my maths is out of it, 0.0. So yeah, we're getting the right reading. So that's line to neutral, so we need to do, that's R1, Rn, so we need to do the R1, R2. So we'll do that, and then that's this ring fine. So I'm happy with this, so we'll do the insulation resistance test on this in a second. There's nothing plugged in. No problems with this, so we can do a 500 volt DC IR test in a second. So a little bit of an update on the EICR I'm doing. As you can see on the lights, hang on, just turn around, I'll show you. So the lights are those types. Now I can't test from those, and the wall light's the same. So we've got to do this testing from the switch, which is over here. So I've got off the wall. So probe, I'm going to stick in probes on those, and over here, as you can see, we've got it jumpered on there, and getting a reading of 0.53 when the switches are closed down, and then nothing at all when they're in the off position, so that's working absolutely fine. So I'll put 5.3 down for the lights, so that's absolutely fine. So that's it for in here, apart from the line that goes back to the main board, which I'm not going to do until that isolator switch is fitted, so I can safely work inside that consumer board. So that's the conservatory tests done. The IR tests I have done on the sockets, both socket circuits, and they both come out absolutely fine. Now, I can't do an IR test on the lights because they're LEDs and I can't disconnect them, so I cannot do an IR test, not without damaging them anyway. So that's a shame, but they'll have to go down as a limitation on the report. Maybe one day the regulations are changing, you can do them as 250s instead of 500, but there you go, what can you do? Anyway, so that completes the testing for the conservatory. I will go outside and I'll show you exactly what I've done to isolate the outside electrics. So behind this curtain, I'll just come around here just a second. You see down there is a fused spur, and if I go out, which is on the conservatory socket circuit, so I come around here, and right, so oh crumbs. Okay, so from inside the house, that a cable, which is actually this one, went into that box, which I've pulled. There's a socket there, as you can see the pipework goes into there. Pipework goes underground. I think I've shown this already in the earlier part of the video, and up to here. Now I've isolated all of this, so there's no power going to that whatsoever now. The power for that is going to come from the garage now, so all of that over there is being ripped out. I'll do that later. I have just noticed, and I didn't notice this earlier on, we do have that. And as you can see, it's a twin and earth cable has gone into there. Now I believe that is actually controlled I did wonder what this switch was. I think it's controlled by that. But I don't think that is part of the lighting circuit. So what I'm going to do is I'm going to take that off the wall and I'm going to see if I get a reading off it. If I don't, then that outdoor light is coming from a different circuit, and I do have a suspicion, I think I know which it is. Okay, so we have solved a few mysteries now. Yes, that indeed does do that external light. Not only that, but it is actually, where it says external electrics on there, it's actually external light is what that's actually doing. So that external electric one is the one that's been causing all the grief, apparently. So I've actually found an additional problem, but I found the external power out there as well. So this is easy to just isolate, just don't use it. Get the MCB off, and at some point in the future I'll fault find that and find out exactly why it's tripping the MCB. My guess is, if we just go back outside again, my guess is, looking at the age of that, water's getting in there somewhere, and also we've got the age of the cable as well. So I'm going to hazard a guess that water's getting in there, that's what's tripping the MCB, because it only seems to happen apparently when it rains. So yeah, it's an old halogen type light anyway, so I think the best thing to do is just keep the MCB off on that, and then that's not going to cause any grief. Yeah, we'll just do that, I think. Yeah, so as I said, it does kind of cut off a bit, but that's about as far as I've been able to go on this EICR. I haven't been able to complete it as yet. Latest I've heard is it's going to be another couple of weeks before this isolator switch gets fitted by the DNO. So yeah, there's not much I can do about it except waiting for that. I don't think in this video it showed that the clips were put onto the incoming fuse. They were done. In fact, they were done before I then did the rest of it. In the other video I've got on this, when I'm fitting all the putting the power back to the garage. By the time I've done that, if you watch that video, you'll see that the clips are all back on the fuses. The DNO came out the same day to do that. It's a shame they didn't do the isolator, but there you go. What can you do? But yeah. But anyway, so I'll do a second part of this video to finish this EICR off, and then there'll be another video that will show the paperwork being done. Which is nice and complete. Anyway, please press subscribe if you found that interesting, and if you've got any comments, please put down below. I'd be very, very interested to hear other people that do inspections about how they would have maybe approached this, or how maybe they would have done it. Would you have carried on the inspection even having found that problem that I found with the tails? Would you have carried on? Be very interested to hear. Okay, and we will see you on the next one.